Let's proceed with the creation of the graphic typology. The typologies are the heart of the program. Therefore, their definition is fundamental for the making of a good catalog and requires a good analysis since we are going to reuse them in the whole tutorial. At this point, we want different typologies. The typologies used for the shell, the ones used for the fronts, other particular typologies for the merged elements, especially for the profile elements, special typologies that may be seen as commonly required to all catalogs. The shell typologies. First of all, let's assign some numbers to these typologies. That is to say that we have assigned some numbers starting from 500 for no particular reason. Let's remember that they may go from 1 to 950. We have preferred this type of setting anyway. 501 is for the typology for the sides, 503 is for the structural shelves, 504 for the genetic joint shelf, 505 for the backs, 506 it's always a type of back, but it's used for the boiserie. We prefer to have a different typology for the bill of material and also for the orientation of the very same typology. 508 is for the glass shelves, 509 are the genetic shelves. The difference to other structures is in the fastening method. And 510 corresponds to the shell, and it's only used for the bill of material, and therefore it doesn't have a graphic representation. Let's take one of the shell typologies, the one of the side, and let's look at it in detail. We have set a description, and therefore the bearing, which is a fundamental element for the bill of material. The bearing shows the shown sizes that are seen from the box point of view. Therefore, the box has bearing LAP, width, height, and depth. And they must be shown along the vein of the panel. In this case, the height is the first size because it represents the panel's length. The depth is the second size because it represents the width of the panel. And the third size is L because it represents the thickness. It's fundamental to correctly set the bearing in order to go to the machine cycle correctly. In effect, some settings for the job already have been created, but we also see them useful for the bill of material. For the position of the genetics that begin from 0, 0, 0, in order to position the side to the left, bottom, and to the rear, the dimension of the side will refer to a variable not defined at the moment, but that we will define it throughout the rule, and it will be for the length and the side thickness. The height is determined, and it's equal to the height of the box, and the depth is equal to the depth of the box. The colors are taken from the variant STR, where the materials code is present on the column 3, and the specialization, that is the mirror image that we will attach to the column number 6. This representation divided by pipe is the standard color normal form. Obviously, we may change it by rewriting the script that designs the element. We see in parameter 9 that the important data pertaining to the coloring of the structure are reported here. Maybe it will be required for the graphics, but it will certainly be required for the bill of materials management. In addition, we have built a subtypology for the right side, where the only difference from the left side is the position of this right side. Said this, let's move on going quickly through the different typologies. Let's observe the position and the dimension of the shelf. Obviously, we try to use as many formulas as possible. To insert a specific position is of no use. To insert a genetic dimension linked to the formulas makes the object very parametric and more adaptable to the context. We also see the orientation LPA change and try to understand the reason of this setting. We also have here other subtypologies. This is the typology that we will use for the structural shelf. It's not strictly necessary, but we have used it. The structural shelves, the backs, the horizontal backs, glass shelves where we have inserted the color of the glass as a fixed color and the thickness of 8 millimeters. The genetic shelf, the shelf which has a LAP dimension of this kind but it also has side 6, lato 6, but if we go to open it, it will say it's not to be drawn. This here allows us to build a shelf. Let's see now the topologies for the frontals. 515, the normal door is assigned to it. 516, it's the glass door. 517, assigned to big drawer front. 519, it will be the small drawer front. Big drawers and drawers usually have different finishes. We have left 518 empty, the eventual big glass drawer, not necessary, but we could use it. Then the 521 represents the internal drawing of the drawer. Let's see the setting we have given to the door. Typology 515. We have inserted the right door where we notice the bearing, but above all, the XP file used to design the door. We'll see later on in detail this file. At the moment, we'll just say that it's a generic file for the doors and handles, and it allows to the graphic animation of the door opening. Regarding the dimensions, we have left an empty space, not leaving the door at full dimension, but with a millimeter per side. For the colors, the method used previously applies. In the finish, we have inserted the number 13 handle 10 plus opening side 3. The opening sides are numbered from 1 to 9. The handles are at intervals of 10, therefore 10, 20, 30, 40, 50. We have chosen the first type of handles and the opening in the 3 position. A position scheme exists which is 1, 2, 3 under, 4, 5, 6 center, 7, 8, 9 top. These are virtual positions because the correctives are made in respect to the handle variance with the script. In this case, we pass several information in the parameters. We have used parameter 9 to carry inside all the information required to manage the handle at the design level as well as at the bill of material level. We have moved on parameter 8, the variables pertaining the finish, the ones that will allow us to download the components linked to the bill of material. We have inserted in parameter 4 the hinges position logic. We'll see in detail later on the details. This is because with a final script we calculate the position of the hinges. In default we have set 2 hinges. The first one at 64 and the second one at H64. We'll better explain this later on. Obviously we have here the left door where only the handle was changed. Before it was at 13, now it's at 11. We also have an end door, which is the door that doesn't have a handle, and I only need it as a filler. We repeat the same instructions for the glass door. Attention for the front, exactly the same to the door, only with less information, since the handle is directly taken from the script using a genetic handle. The same thing for the drawers. For the side of the drawer, we write some information not managed from the beginning. For example, the content of the guide variant of the drawer that will be required to download a hypothetical bill of material. At this point, let's complete the shell with the latest typologies linked to the shell's completion. The top, the shelves, the plinth, the lateral plinth, the 3-dimensional genetic objects that may be needed to position accessories, and the processes on the top that later will be required to manage the rest of the linear elements. A last thing about the management of the special settings. On the special settings mask, we insert the top typology, the incidence typology, or top processing, a description, top, the type of Boolean operation to perform. This will allow to certain automatisms. Let's look into them. Top typology, incidence typology, cutting typology, which hasn't been defined at the moment. This allows to cut the top in 2 parts, or it forces the cut. Edge typology, that requires a pretty specific thing. Machine transfer, which we will see later on for the machines. and the visualization type. We may repeat this for several typologies, therefore top and shelves may be combined together. Some flags may be inserted at the beginning. For example, 3000 shows, attention, the top can't go over the max length of 3000, otherwise it will be cut. Or A, that indicates the maximum length must be defined in the registry, or T, which indicates that the top mustn't be designed but only counted as quantity in the quotation, etc. These are all settings that we may change later on. For the time being, let's block the top's maximum length at 3000. We have repeated the same thing for the plinths. Obviously, in a catalog, it's possible to have much of this information. We have here, for example, gone to a client catalog in which we see a variety of operations that are made at the Boolean level. These operations can be more complex of the ones we have seen so far, but we will describe them as we go along. Let's describe them one by one. 500. The group typology is required to gather more elements using the level management. It's necessary to better explain it by creating a real example. We could define a drawer level which is formed by another drawer level, and each drawer is made by a series of components. This mainly concerns the bill of material. 700. It's the code category which allows to download the codes or to carry them to quotations linked to the item. We will use this to insert the elements code which are part of the column or of the base, but they are taken in consideration separately. For example, the accessories rather than the ovens, the cooking hubs, and things of this kind. 701, the draggers, is a system to make the rule allow a stretchable interface. They are required to change the dimensions of an object by just using the mouse. 702, the text typology, can be seen with an example on what we have previously done. Remember the message box? That wasn't very comfortable. It was more comfortable to replace it with a text typology. Let's see its use by re-entering into the previous rule, where we have explained the message as message box and inserted the 702 typology, where in the code we have written this instruction: replace, not to CRLF, but with /n, which is the indication that we have inside the rule for the carriage returned. This allows to directly have a label that shows a message inside the graphic. The dimension and the settings of the label may be arbitrary, and it may be positioned in any 3D position. We must remember to enable the text visualization or the labels won't be seen. Let's go back to the rule. We have inserted two sub-typologies that allow us to have labels of different shapes. Typology 703 allows us to insert genetic dimensions inside the rule. It's also necessary to explain it with an example. We have inserted inside the box a 703 typology positioned at depth 4, height A with width L, and for code $L. The result is a 3-dimension dimension that will be a complete representation of the object. 710 is a footprint typology. It is not necessary since the footprint is automatic when not set in this typology, but it could be useful to see what's the footprint of a box or to be able to modify it from the user's standpoint. Let's insert the 710 typology, exit the rule, and we see nothing. Let's go to the movement mode, activate the footprint visualization, and here that we see it this way. We position inside it the objects that will be represented. We have created 26 typologies, 5 genetic type sub-typologies, which are linked to the shell, and 2 are linked to the genetics. Of these 26, 6 are managed by the typologies that are useful for every catalog. With this, we propose again to draw anything inside the catalog. Let's proceed with the creation of a shell now.